Welcome to part 14 of the video series on the LinuxKI toolset. Today we'll be covering the Kparse report, which provides a high-level overview of all the data from the various text-based reports we've covered so far. We discussed the LinuxKI ASCII trace file in part 4 of the series. At the time, I mentioned that we would build our knowledge about LinuxKI from the ground up, and that we normally do not start our analysis with the trace data. Parts 5 through 13 covered the various text-based reports generated by the KI-all script. But analysis for LinuxKI often starts with the system overview report, commonly known as the Kparse report. The Kparse report is an HTML-based report that provides an overview of the data from the various text-based reports. Again, Part 4 covered the LinuxKI ASCII trace data, while parts 5 through 13 covered most of the text-based reports. The Kparse report can be found in the HTML file beginning with the letters KP. In order to view the Kparse report as an HTML file, you'll have to have HTML access to the directory where the data resides. Note that you can generate the Kparse report as a text-based file by executing the KI-all script with the -x option. Next, we'll take a look at a Kparse report from a customer system. At the beginning of the Kparse report, you'll find some basic information, including the command used to generate the report, as well as the version of KI-info. Note that this is the version of KI-info used to generate the report and not the version that was used to collect the data. You'll also find some basic system information, such as the uname output, the number of CPU cores, the number of processors, also called sockets or NUMA nodes, the Linux boot command line, and some basic memory information. If the LinuxKI data was captured with the LinuxKI version 5.8 or later, you will see some details about which kernel side channel attack mitigations are implemented. You would also find information on hyperthreading, sub-NUMA clustering, and whether or not the system was actually a virtual machine if any of these features are implemented. Next, you'll find the table of contents. Notice the report is divided into distinct sections. Section 1 contains CPU-related information. Section 2 contains information on various wait events, and these sections are followed by the file, disk, network, and process memory sections. You may also see an Oracle section and a Docker section if available. The Kparse report makes extensive use of HTML hyperlinks to help you navigate through the report. So we can simply select on the hyperlinks to move to the next section or the next subsection in the report. At any time, we can go back to the table of contents, where we can then select on any section or subsection in the report. The first section helps answer the question, when it's running, what's it doing? Most of the CPU-related data in this section is also reported in the KI run queue and the KI prof text-based reports. Again, we can navigate through the report using the next subsection links. Note that the PID numbers are hyperlinks as well. If you click on one of the PIDs, a new browser tab is opened up that provides the PID analysis report from the KI PID file for that specific process. Section 2 helps answer the question, when it's waiting, what's it waiting on? Most of the data in this section can be found in the KI wait report, the KI run queue report, and the KI futex report. Section 3 contains data about the file activity and can also be found in the KI file report. Section 4 contains the disk I/O activity and can be found in the KI disk data. Section 5 contains the network socket activity, which can also be found in the KI sock file. Section 6 contains the process memory statistics. Data from this section is unique to the Kparse report, but is derived from data in the KI PID file. Section 9 provides various links to the files generated by the KI-all script, or supplemental files collected by the LinuxKI script. If you click on one of the report files, a new tab will come up with the specific report. In this example, we selected the PID analysis, or the KI PID report. Finally, one of the key features of LinuxKI is the ability to identify known issues that can impact performance. The warnings indicate that a condition may exist, but further analysis may be required. If you select one of the warnings, the report will go to the specific subsection where the condition was identified. In this case, evidence of the network latency tuned profile is identified by the presence of the SK busy loop function in the CPU profile data. If you select the info link on the warning line, a new tab will be raised in the browser that provides additional information about the LinuxKI warning from the LinuxKI GitHub page. This data can be used to verify the issue and potentially resolve a performance issue. Selecting Next will advance the browser to the next warning in the report. Again, you can select the Info link to get more information about the reported warning. For additional information on LinuxKI and the Kparse report, be sure to check out the LinuxKI wiki page. You can find links to the various LinuxKI warnings, and complete documentation on LinuxKI can be found in the LinuxKI Masterclass. Thank you for joining and have a great day.